soon. Happy Friday, everybody. Let us begin. Music, background music. All right. Welcome everybody to the stream today. It is Friday the 13th, actually. That's interesting. I didn't realize that until just now. It is Friday the 13th. So, happy Friday the 13th. We do have some crazy weather where I am right now, so if the stream inadvertently disconnects, I do apologize if that happens. I'm hoping it doesn't. Not hearing the sound, so I'm not sure what is going on with the sound right now. Let me see if I can get that fixed. Okay. It's not monitoring for me, but I wonder if it's playing for you guys. I don't hear it in the monitor though. Where is the music side? Let me just remove this. Yeah. Main. Okay, there's the music. We got it now. Okay. So, Friday 13th, welcome to the stream. Without further ado, let's get started. What were we doing yesterday? I'll tell you what we were doing. We were playing around with malloc. Remember, we struggled through that malloc with type conversions with C and with strings. So let's go ahead and just remove this whole buffer and we'll start over. So let's go ahead and include our standard input.h. We know we're also going to need the standard, we don't need anything else actually for this, do we? Okay. So we'll do our main function, being sure to return 0 with a happy call. We'll do a char of 10 characters. And we'll do a float f of the value for pi, 3.14159. And then we're going to do that sn print f, which takes in the destination, the size, and the string formatter, and then the value that you want to convert to a string. So that's converting numerical values to string, and then we'll print it out. The string value is, of course, and then it's a string, and then we'll be sure to not forget our new line, passing that in, and we'll save it, and we'll compile, running make, and implicit declaration of sn print f. I don't know why it does that, even though we have the include specifically up here at the top, so I'm not quite sure if it has something to do with my make. If you know, chat, if you have any idea what's going on with that, please do let me know. Let me just say hi to chat. Hi to chat. Happy Friday the 13th. Lego. Okay. So I said hi to chat, and chat will say hi back to me because chat likes talking to me. Don't you, chat? Don't leave me all alone, chat. Okay. So we compiled, we finished the compilation. Let's go to the terminal and let's go ahead and run it. And we'll see that the string value is indeed that. And then we kind of played around with doing instead of using char as that, saying we're going to do a char pointer as S, right? And then asking for a malloc of declaration here. So we'll go ahead and move this down there, and we'll compile again. And I still have the implicit declaration, but it's not really the implicit declaration because I did declare it. And then why is it saying it doesn't like standard lib up here? What is the error for that? Key binding is discouraged, I understand. Is it saying that it wants to order it or something? I don't know. Let's go ahead and rebuffer everything. It indented it. Okay, we'll compile again. We've compiled again. Okay, now there's no errors. Weird. I don't know. I'll have to figure that out at a later time. And then the string value, of course, works again by using malloc and giving our own values for the string. Now, what would happen if we were to add more values onto the end of the string? Would we just get the values that giving to us? Again, I don't know why it's doing that with the compile. Would we just get the values that are given to us, or would we get a segmentation fault? We get that extra value because we took in 10. So if we said we only wanted a malloc of size, we only wanted this to be size like 5, what would that do? What would that do for us? Let us see what that would do. Of course, we get the warning again. I'm not quite sure why we're getting the warning so much. You know what I'm going to try the next time we make a change is I'm going to try to do it outside of Emacs and see if it has to do with some kind of bug within Emacs that's doing that to us, because it is quite annoying. Look at that. 3.14, so we did only get 5 digits, including the null terminator. When we set the sprintf function here, the second parameter here controls those values. So that was interesting. So that is a learned thing that we just learned about. So let me change that back to 10, and then instead of compiling there, I'm going to compile in the terminator this time by saying make main. Look at that, it does it again. If I make main again, it goes away. So I don't know why it's doing that. I think it might be something that means that it's something within my, there we go, we're back to our correct determination of the 3.14 is what we want there. And then we'll make it again, we'll compile again, make, of course we're going to get that craziness. Who would have thought we would have got that craziness? And then we have 3.14590. So we don't really want that. String value 3.15, yes, because it adds the extra value. So let's quickly look at the man page for this new function that we're using, the snprintf, and see what we see. So it's just printf and everything. So let's see, what's the sn portion say? Feature test macro requirements. Feature test macro requirements. So we did need a feature test macro requirement for it. Okay. So that feature test macro requirement, it would be the ISO. So what XDO open source or glib is greater than equal to 500, or the ISO 19 source equals or ISO 99 source. So I guess I could just do that, right? Let's see if this macro stuff is actually working here. And then we go back up here, and I think I just have to do a define, and then that, I believe. So now if we compile again, and still says is defined in header. This is probably fixable by adding. I did add the header. So why, oh why? I don't understand why it's doing that. Since glib snmprintf, that's what he's using, snmprintf. Open source is greater than equal to 500. Since glib glib less than or equal to BSD source. Okay, see feature test macros 7. So feature test macros. So let me do that. Man, feature test macros. Okay. So where you do define? Yeah, so define and then the value X open source. X open source. X open underscore source. Okay. So back to that man for sprint. X open source is greater than or equal to 500 or ISO. Okay, so what? Stir do. Greater than or equal to 500. Or since glib POSIX source is greater than or equal to does that mean I put it in? Yeah. Or any value less than 500. So why? I just don't understand why I'm getting why it's complaining during the make file. Main GCC flags main.c. Is it because I'm including this O here? I don't know. I'm just going to try something. Maybe it is, but I think that if I don't include that O, then it's not going to compile at all. Oh, it did. Wait. So because of that object? What if I recompile? Okay, so it's not. It's, yeah. Yeah, so it is that. I do have to have that O. That's why I thought I had to have that O in there. Because that's what the output is. Or, I mean, I guess I could just put it down there. Right? But it's a flag, so I don't need to put it down there. That's why I put it up there. Yeah. Okay, so if we go back to our C file, define ISO 999 source, but it doesn't. I want to stop getting that error. That's what I want. And I don't know why it's doing that. I don't know if it's a bug in the current GCC or what's going on. It's saying the feature test macros I need to use, so I'm just going to use the X open source, this one right here. Okay. And let's define. Okay. Look, it still does that. Implicit declaration of function is defined in header. This is probably fixable by adding exclude. I did add exclude. Do I have to do an extern? I don't. You know, because I don't even know what the I don't know what the signature is, so I don't want to do that. I think that's something I have to figure out later. I'm not going to let it throw me off from what we had planned today. Okay, so strings to numeric. There are a couple families of functions to do this in C. We'll call these the ATOI, pronounced A to I, A to I family, and the struto, pronounced stir to long family. For basic conversion from a string to a number, try the A to I functions from standardlib.h. These have bad error handling characteristics, including undefined behavior if you pass in a bad string, so use them carefully. Looks like that might be a little bit loud on the music. I'm going to turn it down just a tad. Okay. Here's an example converting a string to a float. Char pi, float, ATOI pi. But like I said, we get undefined behavior from weird things like this. What ain't no number I ever heard of. When I run that, I get 0 back, but you really shouldn't count on that in any way. You could get something completely different. For better error handling characteristics, let's check out all those string to long functions also in standard lib. Not only that, but they convert to more types and more bases too. String to long int, string to long int, string to unsigned long int, string to unsigned long int, string to float, string to double, string to long double. We should make a whole ditty about that. String to long int, string unsigned the long int, string my double with my dog. Okay, these functions all follow a similar pattern of use and are a lot of people's first experience with pointers to pointers. But never fret, it's easier than it looks. Let's do an example where we convert a string to an unsigned long, discarding error information, i.e. information about bad characters in the input string. Yes, let us do that example. So, do we want to... man, because this didn't do what I wanted, so I don't understand why it's barking at me for this. What? Why is it barking at me for that? Not sure why it's barking at me for that. It says that the function was declared here, explicit. It wasn't. I did the standard input lib. Don't understand why the compiler is compiling like that. You know what I could try? We could try Clang, because we did download Clang. If GCC is not going to play ball, so we have Clang, right? So we have Clang main C to main. I don't know how to use Clang. I'm assuming it's main C to main. Clang linker command failed with exit code. Use V to see invocation. Sure, use V. Whoa. What? Ubuntu target. Boom. Include search starts here. User bin. Cannot find executable main. Cannot use executable file main as input. Ah. Yeah, because I shouldn't have done that. Shouldn't have done that. Cannot use executable file main as input. I didn't. Yes, I did. Main.c. Oh, main? Okay. I didn't get no errors. What? What? GCC version. So what version GCC am I using? 15.2. And when I do make clean, so I do make again, I get those errors. So let me do make clean, and then let's do cling again. No errors. So are they saying that Clang is better than GCC? Warning, implicit declaration of function. I did add include standard. Is it? I don't know why it's doing that. I don't know why it's not finding it in the... So let me do make clean again. What if we make clang... I mean, so clang, does clang have man clang? Let's see, does clang have extra as well? Extra... No. Let's see. Man clang, does it have like W extra? Like GCC? No, it doesn't. So, how do I get to errors then? Error. Preprocessor commands. These options, okay. Control how clang prints out about diagnostics. Show. No, I just want the most errors. Specify which optimizations to use, target, strings, all kinds of stuff. Well, specify the standard lib, yeah. Working for C, GNU. Amendments for GNU extensions. C 89. Okay, so we do have standard. So I could do it with clang standard equals C89. Main. Oh. Main.c. Include the header file or explicitly provide a declaration. I did include the header file. So if I run it again, no, it's explicitly declaring library function. So it has nothing to do with, it's just a bug in my library or something? Like, let me delete it. Oh, sorry. Let me delete it, and then obviously when I compile, it's gonna break, right? I mean, obviously it's gonna break. There's, yeah. And then if I then include it, yeah, standard, right here. There it is. So I've included it twice. It was the wrong one to include. Compile. Is defined in the header. This is probably fixable by adding include to H. So you want me to add it again? I mean, sure. Whoops. What did I just do? Sure, I can add it again. I don't remember what crux duplicate line is. Duplicate Control CD. Okay. So I added it again. Let me compile again. I can add it. I'll add it again. I can add it as many times as you want me to. All night long I can add it, but it's not going to change the fact. I don't. And then the second time it goes away though. So that's what the really weird part is. So So I'm gonna just close this buffer at this point, and we're gonna open up a, let's call it stir convert, I guess. We're gonna open up a, let's do a new, well, no, it still is conversions, isn't it? So, stir long ones, better.c. Okay. So let me include standard io.h. Is that where it is though? Man, we're not using the s in print. Okay, so we're using the stir ouls. Man. String to OUL. Yeah. Feature test macros for glibc. Standard lib.h. So that one for sure is probably going to bark at me again. So let's just go down the path of resistance. What is this? What was that? Come on, Prelude. You're supposed to be helping me with stuff, not giving me issues. Where's standard lib? Look at that. It's not even there. There it is. Okay. So int main void return 0. We'll do a char pointer to this number, what, 34 something? 3490. Okay. And then unsigned long int x equals strtou. Yeah, this one. And we need s null and 10. Okay, so are we also going to get an error for this? Oh, we can't have unsigned long int x. We don't want to do x. Oh. We don't want to implement those beforehand. Print f percent lu n and x. So that's what we're expecting to print out. Okay, so let's go back into our make file now and put a new target in here for, what did we name that file? Better, okay. Better takes better.c, does GCC with flags, C flags, and better to better from better.c. And then we would be removing better as well. Okay. So let's go back to our C and then we'll compile this. Make better. That worked. So I think it's a, is it a bug in my buffer? It's a bug in the buffer. A bug in the buffer. A bug in the buffer. What? A bug in the buffer? A bug in the buffer. It has to be. How else would it work? So What do you think if I remove that buffer? Okay, let's try something. Let's transition back. Let's transition back to main. Okay, so let us try to go back, because it worked, right? It didn't give us no errors. Better. There it goes. It worked. It didn't give us no errors. So let's go back to our previous main. Okay. And what if I... Oh, man. So if I compile this now, and I just do make main. Oh, it finished. What? No. Let me add a comment in here. This is a comment. I don't know now. I do not know what I have no clue. I am lost for words now. Because Better C didn't give us an error at first at all. Right? If we recompile this. Oh, it compiled main. We'll compile this. And we want to do better. It doesn't give us no errors anymore. So is it a transient thing? Is it makes me, because it wasn't the make file. Oh, it could have been the make file. Was it a transient error inside of the make file? What do you think, chat? Was it a transient error inside of the make file? Because I can't figure out what it was. And I'm over here typing away, trying to figure it out, looking up for if there's a bug somewhere, and it ends up being some weird transient error. Okay, let's move on. Notice a couple things here. Even though we didn't deign to capture any information about error characters in the string, won't give us undefined behavior. It will just return 0. Also, we specified that this was a decimal base 10 number. Does this mean we can convert numbers of different bases? Sure. Let's do binary. Okay, let us do binary. Let us do binary. So let's go back up. We'll make another char. We'll call this B for binary char. And 101010. We'll call this one unsigned long int BL. Why not? I don't have a better ideal for it. And then BL equals string to OL, yeah. And we want it to be B and null. Oh yeah, because we did null last time. And the base is 2. Okay. And then if we print that out, %LU still, and then %N, and we want it to be our BL. Then we can compile this. Compilation finished. And then let's do better. 42. So we converted the string binary to base 2 to an unsigned long int of 42. That's kind of cool. Okay, that's all fun and games, but what's up with that null in there? What's that for? That helps us figure out if an error occurred in the processing of the string. It's a pointer to a pointer. It's a pointer to a pointer to a char, which sounds scary, but isn't once you wrap your head around it. Let's do an example where we feed in a deliberately bad number, and we'll see how Stro let us know where the first invalid digit is. Okay, so we need a pointer to a char. think he's going to call it, yeah, bad char. That makes sense. And we're going to give S an invalid number this time. So let's do 3A. Okay, so we'll give S 3, 4x90. Okay, and this time for x, we're going to type in the pointer to the address to char. The address to the pointer. That helps figure out. It's a pointer to a char, which sounds scary, but once you wrap your head around it, okay. And then we could print out what the bad character was. Okay, printf invalid character %cn, and then the pointer, the value in bad char. Bad char. Okay, so let's compile this again, and then let's run it. Invalid character X. So it did, as far as it could, it stopped it to invalid character X, 3, 4, and did the rest. Very cool. Man, I could have used that. Oh man, I had to write a parser to parse out numerical values at work using expression language inside of Azure data flows, and that was way more difficult. This could have kind of just did it. It could have just grabbed the numerical, because I was doing a right to left kind of greedy search inward. And as soon as it found one that was valid, it would, so you don't say that's the best guess. And that was good for that domain. That was good enough for what we need. It wasn't perfect, so it would still sometimes give the values. It would always convert it to numerical, but it would sometimes give the values that didn't numerically make sense for the domain at hand. But we had a secondary cleaning system that would do that. Okay, so now, we have Stro modifying that bad char, what bad char points to in order to show us where things went wrong. But what if nothing goes wrong? In that case, bad char will point to the null terminator at the end of the string so we can test for it. So there you have it. Okay, the null terminator at the end of the string. So if we go back up here and we change that back to change that back correct, then it's going to just be a null value, I guess is what they're saying. Invalid character is nothing, or the null terminator. Okay. Char conversions. What if you have a single character with a digit in it, like 5? Is that the same as the value of 5? Let's try it and see. Print F55. On my UTF system, this prints 5 and 53. Right, so no. And 53, what is that? That's the UTF-8 and ASCII code point for the character symbol 5. So how do we convert the character 5, which apparently has value 53, into the value 5? With one clever trick. That's how. The C standard guarantees that these characters will have code points that are in sequence and in this order. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Ponder for a second, how can we use that? Spoilers ahead. Let's take a look at the characters and their code points in UTF-8. 48, 49, yeah. You see that 5 is 53, just like we were getting, and 0 is 48. So we can subtract 0 from any digit character to get its numeric value. You see that 5 is 53, just like we were getting, and 0 is 48. So we can subtract 0 from any digit character to get its numeric value. So it subtracts the code point. So char C equals 6, int C equals C. C has value 54, the code point for 6. Int Y equals C minus 0. Y has value 6, just like we want. And we can convert the other way too, just by adding the value on. Let us try that, because I've done that stuff in Python before. So char C, we want an int. Let's do int y, and we want an int z, I guess. Okay, we're gonna say C equals 6, and we're gonna say y equals C, and we're gonna say z equals C minus 0. And then we're going to print that out. Value of z percent C, and then z. Compile that. Warning, was set but not used. I did use... Yeah, why was y set and not used? Y has value 6 just like we want, and we can convert the other way too, just by adding the value on. That's fine. I'm not really worried about it. I just want to see it work here. Value of z is nothing. Why is the value of z nothing? Oh, because we want the decimal value of it. Decimal value of it. Still nothing. 6, yeah. Okay. And we can convert the other way too, just by adding the value on. You might think this is a weird way to do this conversion, and by today's standards it certainly is. But back in the olden days, when computers were made literally out of wood, this was the method for doing conversion, and it wasn't broke, so C never fixed it. Numeric conversions. If you want to convert a 0 to bool, the result is 0, otherwise it's 1. Perfect! 0 to bool, the result is 0, otherwise it's 1. That's correct. Integer to integer conversions. If an integer type is converted to unsigned, it doesn't fit in it. The unsigned result wraps around odometer style. Yeah, so that's wrap around. Integer and floating point. Implicit conversions, integer promotions. The usual arithmetic conversions. Explicit conversions, casting. You can explicitly change the type of an expression by putting a new type in parentheses. I skipped all that casting stuff because that's the all languages since C have pretty much followed C's casting rules, so we don't need to belabor the fact on that. You can explicitly change the type of an expression by putting a new type in parentheses in front of it. Some C devs frown on the practice unless absolutely necessary, but it's likely you'll come across some C code with these in it. Let's do an example where we want to convert an int into a long so that we can store it in a long. Note this example is contrived, and the cast in this case is completely unnecessary because the x plus 2 expression would automatically be changed to long int to match the wider type of y. In that example, even those casting. More commonly, you might see a cast being used to convert a void pointer into a specific pointer type so it can be dereferenced. A callback from the built-in qsort function might display this behavior since it has void pointers passed into it. Int compare, constant, void element, and then int pointer to the void element is greater than int pointer, but you could also clearly write it with an assignment. Constant int void pointer equals the element. One place you'll see cast more commonly is to void a warning when printing pointer values that are rarely used, %b, which gets picky with anything other than a void pointer. Yes, it does. I ran into that yesterday. Okay. With the rarely used, which gets picky with pointing anything to avoid. Int x equals 3490. pointer int as an address at X, and we want to print P generates this warning format. Since P expects a type of void, but argument type 2 as int pointer, you can fix that by casting it to a void pointer. Another place is with explicit pointer changes. If you don't want to use, I actually want to try that out because I have run into that before. I don't have a lot of int stuff left. Let's say int. Oh, we already have int x. Okay, cool. Let's do, yeah, a pointer P equals the address of x. If I can find that key on my keyboard. And then we'll print it out. Printf. Boom, 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 boom. Address of x percent %p and p. Yeah. Compile that. Is it gonna complain in the compilation? Yes, it even complains in the compilation. Okay. We'll go there. Initialization from incompatible pointer long unsigned int. Where? Why is it long unsigned? Oh, because we had x there. I thought. Yeah. So I need a different. Let's do int k. That's my name. K equals 3490. And we'll change that to K. Now we compile. Now the only error we should get is the... Where did I declare code? Oh, there? Of course I did. Why wouldn't I? P equals that. There we go. Compile. What? Which one am I? Oh, because the K there? Ay. There we go. I do want to be pedantic with that stuff, but okay, so there you go. The void. So we can go down to where the print is, which is the K. Go. Whoops. Y. Relux error. I could just. So now we're going to wrap that into like that. Now when we compile, we get no errors. And then we get our address. Oh, and look what I forgot. I forgot the freaking new line character. That's what I do. I forget the new line. I'm gonna add, like, so that's gonna be something that whenever I forget that, I'm gonna have a keystroke and like something's gonna pop up on a string that's like cool. But I have to program it. I'm probably gonna use like Raylib or something like that to do that. That's something I definitely want to do. And I also want to spell stuff correctly. Definitely want to spell stuff correctly. So how? Oh, that spelled it for me correctly. I like that. And then I need to do that new line. So what is the what is it called? Key chord. What is the crux? Key chord. No, prelude key chord. Oh man. I could define key, I guess. Would that work if I do control at key and... Oh, it does. Okay. key chord JJ is to the AV go to word. Okay. And I want to go AV go to char. So where's AV? AV go to char. So we want to AV go to char. And that is key chord. I thought we had AV go to char. Let's look at the usage right here. Sorry if that's bright. AV go to where is the key chords? Prelude mode, modifiers, helm, key chord, go to characters, JK. Okay. JK, so because I want to change that quote there. Oh. No, JK. Yeah, after the P there, I want to change LH. There we go. And then we can compile. And now we will have done. Address is on that line now. Okay. Alright, cool. Back to the guide. So that's where we are. Alright, so we finished chapter 15. Where does that put us at now? This puts us down to qualifiers and specifiers, and then multi-fire projects. Qualifiers and specifiers. You're not qualified to tell me what qualifies as a qualifier and specifier. No, you're not. You don't get to tell me, I get to tell you what specifies as a qualifier and a specifier. Beach. Okay. Let's go there. So this has const as a section, correctness as a section, restrict as a section, volatile as a section, auto as a section, static as a section. But you know what? If it's not in the C89 specification, I'm probably not gonna. C89 keywords. So constant's there, volatile is there for C89. What else did they say? What else was it? Restrict. Restrict is C99, so I'm not going to use that. Atomic, I can guarantee that wasn't there. Atomic is C11, so I'm not going to use that. So we're just going to do const and volatile. So this is the most commonly typed qualifier. It means that the variable is constant. Any attempt to modify it will result in a very angry compiler. Compiler puking sounds, can't assign to a constant. You can't change a constant. Often you see constants in parameter list for functions. Okay, doesn't modify X. This one gets a little funky because there are two usages that have two meanings when it comes to pointers. Oftentimes you'll see constants in a parameter list for functions because you don't want the value to change inside of the... Okay. But doesn't it make a copy on the stack anyway, so you wouldn't be able to change it? Like if I pass in int x to a function, isn't that essentially like... let's just test it, because we're doing nothing else right now. So we'll just do test.c, and we are going to have to include our friend, standard input.h. We're going to do a main function. We'll return 0. We'll print hello. foo, and foo takes in a constant int x, right? And it just wants to print out that %d and x plus 30, right? But we're saying I'm unsure about the constant keyword, so I want to see if x plus equal 30, right? And then I'm just going to print out x here. Okay. Int x equals 10. We'll print out the value of x here. Value of x before the function, foo, %d, and then x. Then we'll call foo, which will print out its internal value of x. Then we'll print f, value of x after function foo, %d, and I'm assuming it won't have changed. Why does it not like foo here? Yeah, because it just doesn't like the naming of foo. Okay, and then we'll compile this. Let's just do this one quickly. GCC text.c. Oh. Well, duh. That was my fault. X. Compile. I always get it in the wrong order, don't I? Text.c out text. There we go. So if we do text here, text here, I mean, value of 40, value of x before 10, foo 10, 40, value of x after function foo 10. So is this just to say, because it's a copy on the stack, right? So is this just to say it doesn't want it to change it inside of the function? So now if I compile, we're going to get an error. Assignment of read-only parameter x. Huh. Yeah, because it doesn't like that anymore. So it wants that to be plus 30, right? And now we can compile, and it's going to be okay with it. And we have hello world. Okay. So we learned about the const today. So we started with 16. On the next stream, we'll pick up with finishing the rest of these. Again, we won't be doing any of them that are C23. We won't be doing. Can I copy this? Let's actually do some Emacs fun real quick. So let's copy this. I'm gonna go to my scratch buffer. And just want this thing here, and I'm gonna post that in there. And I want to go to the top of the buffer, and I want to remove any lines that have. So what we want to do is we want to narrow. Oh, I guess we could do an occur. So I could do an occur through regex, right? So I could do this. Well, that's query replace. But could I do an occur buffer at that point? No, I just want to do query. Okay, so let's do cancel out, and we're going to do meta s. Nope, it's not that. It is control meta s. Where's occur? I want to do occur regex. Regex, yeah. So I want to do list lines regex. So they begin with, and they begin with that, and then they have A to Z as many times, and then they have a space. Why is it only 10? They all begin with A to Z as many times. So, regex, visual reg. Do we have visual regex? Visual VR? No. Do we have regex? AG regex? Eval? Highlight. Highlight regex. Regex to highlight. No, I want the regex in line to so I want the lines that do not include that. So that's the regex. Let's do occur again. Occur. It is here, star the, but they don't, does not include C star like that. I guess I could just take the first to the end of the letter. No, because that would be. Let's figure this out. Oh, someone's talking here. Sorry, I didn't notice your chat. It's very quiet. Oh, why is my mic quiet? I didn't know that. Let me turn it up a little bit more. I didn't realize it was quiet today. My apologies for that. Glad you stuck around. Hello. Good to see you, the Jinx. Good to see you. I am doing a regular expression, playing around with regular expressions. But I'm making a mistake here. So, occur. Okay. So I want the beginning of the line. You know what? Let's just look at the manual. So Control HI and then topic M menu regular expressions. Oh no, let's do R. Nope. How do I search the menu then? Regular expressions. Quit. List all the commands. List all info commands. Okay, H. Search through this info file for specific. Oh, S. Okay. So S, regular expression. Search failed. Okay, so it's not what I. Okay, thanks for letting me know that it was low. My camera also seems grainy right now too. I think it's because I'm on a non. I gotta get a better green screen. My green screen actually sucks. I can show you what it looks like without it. It's not good. I need to get a better one. So like if I turn off my green screen, it actually probably looks way better. The camera looks better, but I need to get a better color for my green screen, or I need to get a better lighting for the green screen. You know, because right now it's just green behind me, but it's maybe the whites are off because the green is way darker than it looks like on here, which means when it does the chroma key to block out the green, it's not showing that color. So I think I need to adjust somehow adjust the colors, and then I'd be able to get the chroma key, and then it would work better. So I'm gonna work on that at a later time. I think for tonight we're gonna end it. It is Friday the 13th. I do want to watch some scary movies with my family, and we're gonna eat some food here in a minute. And then tomorrow is my birthday, so I'm not sure if I'll stream tomorrow. I will still try to put out one of my shorts, but I thank you guys all for joining. Let's go quickly look at our channel, see where we're at with our channel. We are at 97 subscribers, so we're only 3 away from that 100. Let's continue to push for that. Like and subscribe. I'll never be pushing you guys to not watch if you don't want. I hope you enjoy the rest of your evening, your morning, wherever you are, and I will talk to you later. This is Keenan Can Do. Have a great